No matter what kind of project you have around the shop, if you're looking for some tips and some help, it's time for Sam's Garage, presented by ARP, with Master Mechanic Sam Memmolo.
Hey, welcome to Sam's Garage. Well, I'm right here in my own shop here at home, and we're going to do a lot of things here, hopefully teach you something. Now, we've got a Jeep here. This is a Rubicon. This thing is loaded out. Great Jeep. And you know how hot the Jeep market is. People are buying these Jeeps. The first thing they do is put winches, compressors, especially if you're going rock crawling. You want to soften your tires, onboard compressors, lights all over them, all kinds of electrical gear, CB radios. Well, if you watch most people, and we're all guilty of this, they run all of the wires to the little ring terminals, put them on the battery, get a ground wherever they can, and you know, before you know it, you got a real problem. And those are the kinds of things that can cause you to have failures. And if you're on the road, off-road, way out in the woods, especially where there's no cell service, and you have a failure, then you're stuck. So Painless Wiring's got you covered. They've got this trail rocker setup. It's got rocker switches. It's a panel designed to fit right in these Jeeps, okay? And it has relay and fuse protection, all the wires, all the quality you've come to know from Painless. And we're going to install it in this Jeep. We're going to do that in a couple weeks. But before we go installing something electrical, you got to have basic electrical understanding. So I built this board here. I know you watch a lot of TV and you see these guys unveil their builds all the time. Well, this is my build. Rather than use a diagram, I decided we'd use a live model, the stuff that you normally touch. Got a nice polished sanding compressor right here. This is from our friends at Vintage Air. We're going to measure and see how much current, amperage, the clutch takes. We got an alternator here. We got some lights. These are old lights I had around the shop. This is actually off my tractor. Flex-A-Lite sent us a nice electric cool fan. This is an S-blade fan. The good news about this, it moves a lot of air. It's quiet. You know, your straight blades are really noisy. They'll sound like a helicopter. This is a high quality fan. Comes with all the bracketry, easy to install. Again, it's nice to see it work. We're also going to measure the current or the amperage that takes. So I've got everything set up. I got a receiver dryer with a trinary switch. We're going to talk about wiring the air conditioner system right through the thermostatic switch with the capillary tube, the on-off switch, trinary switch, because a lot of guys make mistakes, a lot of guys and gals. And of course, you know, you got to have a couple of basic instruments to check things with. I like using this. This is my Power Probe, and this is the new Power Probe Basic. It's really simple. This is affordable. Anybody can have one of these, and everybody should if you're working on your car. They're really a lot better than a test light. You can do a lot of things with it. Nice set of leads, 20 feet, and they put a plug on the Basic. So you can add a set of extension leads if you're working on a trailer or something. I'll show you how this works. Let's talk about a basic circuit first. I built this using an old trailer taillight I had, and a circuit comes from the word circle. What we have here is we have our battery positive, and we have a ground here. I'm going to show you everything I've got is going to be dedicated grounds. That's the only way to go when you're wiring your car. Using sheet metal screws here and there, going onto the chassis, using it as a bus bar, not going to cut it. So what I have is wire coming out with a fuse holder. You see how close the fuse holder is to the power source. The closer the better. That way, if you have a problem, the fuse is protecting the circuit. If you have any kind of an issue, the short wire gets burned. So we come out of the power supply through the fuse to a switch, no different than any other switch you've ever used, to this light, through the ground, back to the ground at the battery. That way the circle's complete. Flip the switch, the light comes on. It's real simple. What you have, when I turn on the switch, the voltage is forcing the current or the amperage through the light bulb's your resistor, back to ground. And you can see it's working fine. That's a complete circuit. We got voltage, we got amperage, and we got resistance. If we didn't have resistance and we hooked the positive to the negative, you know what would happen. The wires would burn or the fuse would pop. And I'm going to show you that right now. I'll take the power wire coming from the fuse holder off the switch. If you look at the fuse, when I go to ground, I'm making the same thing, a complete circuit. Nothing's different. When I do that, bang, the fuse popped. If I didn't have a fuse, that's a short circuit, by the way. That is a true short circuit. If I didn't do that, didn't have a fuse, I'd burn the wires. So we plug it back together, and now it doesn't work. The reason is the light is your resistance. You got to have resistance, or the current flow will be so much that the wires in the fuse can't handle it. So, now here's a great way to check this out. I'm going to show you how to diagnose this circuit. I'm going to show you about trinary switches. I'm going to show you current draw. We've got a lot more we're going to learn here. Hopefully this will help you out. We're going to take a quick break. Stick around.
Sam's Garage, presented by ARP, is brought to you by Vintage Air, the inventors of performance air conditioning, celebrating 40 cool years. ARP, proudly made in the USA, the world leader in fastener technology. LMC Truck, restore, maintain, customize, parts and accessories for Chevy, GMC, Ford, and Dodge trucks and SUVs. And by Power Probe, an absolute must for your toolbox.
Welcome back to Sam's Garage. Okay, so we blew the fuse. That means the circuit's no longer complete. Now you got to check it. I'm using the Power Probe Basic. I like this thing. Now they make all kinds. They've got them with a voltmeter on them. They've got them with headlights. But this is affordable, so any of you guys can afford it. You hook it to your battery, and then right here I got a dedicated ground. So the little ground lead goes to a ground. If you push the switch back, that's showing you that you're on the ground side. If you push the switch forward and the red LED comes on, that means you're getting battery voltage at this tip. It's a great way to go. You can actually do a voltage drop or find a dirty ground. Real simple. I go to ground, you see the green light on. When I push this button, I'm going to send battery voltage to that, which would be a short circuit, except what it did, it tripped the circuit breaker inside. If there's no switch, the circuit breaker resets itself. Real handy to use. If it won't pop the circuit breaker when you do this and push the button, the ground's not good. So that's a great way to find a ground, and you can feel it. If you got it in your hand, you can feel it, click it. Also, if you're working by yourself, they got this nice little deal that clips on over and locks the switch in place. That way you don't have to stand there and hold it. Makes it great for one-man operation. Also can do some diagnostic work. We go here, we got battery voltage there, we can see that. We know this fuse is blown, but if we check a blown fuse, there's one side of it's got battery voltage. Then we got here, we got a circuit, but we don't have any voltage. So I'll go ahead and I'll push the button, send voltage to the tip, and the light lights. This is a great way to go. If you were suspicious that it wasn't the fuse, you would go back to the switch, push the button, go right here to the light lights. That tells you that from the switch, the wiring, the connection, the light, all of that works. It's a great way to troubleshoot. So now I'm going to go ahead and change that fuse because it is blown and I want it to work, because the next thing we're going to look at is how do you figure out how much alternator you need. If you're building a T-bucket that doesn't have a lot of accessories on it, you're not going to need a lot of power. But you're going to build in a big sedan like my 39 Chevy or my 40 Ford. You're going to have an electric cool fan, you're going to have air conditioning, you got squirrel cages. So let's start off with a good alternator. Now, some of these cheap ones are rated at 100 amps, but they don't tell you where it puts out. You have to go 100 miles an hour to get that. If you're only putting out 15 to 20 amps at idle and you're cruising through the fairground, you're going to have a dead battery. And let me show you how to check that. Okay, this is an inductive amp clamp. You put it over the battery cable and it'll tell us exactly how much current is flowing. So let me put on the lights from my old Chevy truck and my farm tractor there. And I'm looking at this and I got 7 amps. I'm on a 40 amp scale, by the way. Now I'll put on a compressor clutch. You can hear the compressor clutch engage. And now we're at over 10 amps, okay? I will put on our Flex-A-Lite electric cool fan. That's from, we're up to 21.3 amps. I put a couple of tail lights on. We're at 24.3 and so on, okay? So that's what you do. If you get up to, I don't have a squirrel cage for the blower motor. If the AC is working, the squirrel cage is running, you got more amperage. If you got a stereo, particularly if you got amplifiers, you got power windows, you got all that stuff. It's easy to have 40 or 50 amp need. So you make sure you get a good alternator and size the wire that feeds the stator. This is going to go right from the battery connection on the solenoid in most cases up to the alternator. You want to make sure you're at least 10 gauge. 12 gauge is iffy, 10 gauge, 8 gauge, or 6 gauge. Like if you buy a painless wire harness, depending on what it's for. Small car with not a lot of accessories, you're going to get a 10 gauge. They'll go all the way down to 6 gauge. The smaller the number, the heavier the wire. Excuse me. Also, you'll notice that all of these have nice heavy wires. All this black shows it's dedicated ground. When you're putting your car together and you're wiring it, don't put grounds all over the sheet metal with PK screws and so on. Go right to the battery. You can get a ground bus, which you connect directly to the battery, gives you a place to attach all your ground points. If you do that right electrically, you'll be in great shape. So with that, we've covered current draw, sizing the wire for your alternator, selecting your alternator, seeing what kind of current you draw. Now we're going to talk about AC switch, wiring up the trinary switch, and the things that can cause you to burn out these switches, because sometimes we wire them wrong. If you're wiring that compressor clutch through this switch, this is only rated at 4 amps. I'll show you exactly how to do it when we come back, so stick around. You know, we've talked about having a few meters, like these little amp clamps. You buy a good one like this, they're not real expensive. By the way, it's a voltmeter, check continuity, AC, DC. You can use it around the house. You can use it for a lot of things. We talked about our Power Pro Basic. That's a great little tool. Stop with the test lights. You can get yourself in trouble with a test light. And when you look at a test light that's glowing, the bulb lights up. How many volts are there? A good voltmeter is good to have. And I'll tell you what, you can buy a good voltmeter for 50, 60 bucks today. And you can buy a more expensive one. This happens to be a good multimeter, but I'm on a 40 volt scale. When you start checking circuits and you're looking for voltage readings, remember, you got to have voltage coming from your battery. So a reference has got to be to the battery. So I always go right to the battery and I read the voltage. And this battery is 12.39, 12.4 volts. A 12 volt battery fully charged should be 12.6. I've been using it a little bit. That's pretty strong. So if you know you're starting off with 12.4 and you get over here and you got 11 volts, then you know you got a voltage drop, you got a dirty circuit someplace, bad connection, bad cable, high resistance wire. But if you don't know what the battery is to start off with, you have no point of reference. So a voltmeter is a real handy thing to have. Now I told you about the trinary switch. Here we have from our friends at Vintage Air, they sent me this nice sand-into compressor. This is all polished. Electromagnetic clutch, like most of your compressors have. This is the receiver dryer. This is in the high side or the hot side of your AC. Then they give you a trinary switch. It comes in the box. Trinary means it has multiple functions. You have to take the plug out of the dryer and screw it in. Now I don't have any pressure on this system, so I've got the compressor clutch just for demonstration purposes wired to the switch. But the trinary switch, it takes care of the heavy wire through the relay, the heavy power through the relay, keeps it off of your AC switches. You got 2 switches on your AC system, your on, off, and blower speed, and your thermostatic switch, which is this one here with the capillary tube, goes down into your evaporator, and that's what cycles your compressor on and off as it gets cold, right? This switch is rated at about 4 amps, particularly on Vintage Air's Gen 4 system, electronic system. It's solid state. It's got, digital stuff in there. Anytime that clutch engages and disengages, there's an arc. That's a voltage spike. Switches don't like it. If a lot of us have, in the past, I've been, guilty of that too, run the wire from here to the compressor, turn it on, the compressor works, you're driving down the road, fat and happy, you're cold, everything's good, but then the switch burns out. It's rated for 4 amps. There's 10 right there, not counting your blower motor. So you don't want to do that because you'll overload your switch. If you look at the diagram Vintage Air supplies, it comes in the kit, simple to follow, and it gives you a lot of options. They supply you with a 40 amp circuit breaker. You want to use that. Come off of your power, go through the circuit breaker. If there's a malfunction, circuit breaker will open, not burn anything up. This will come up to your relay, and of course, you follow the schematic. This gives you heavy battery current to the relay. The relay is just an electronic switch. I'm going to tell you about those. And also, this is our cool fan. We got a 12 gauge wire and a 12 gauge wire. All the relay does is hook those two together, make the cool fan run or the compressor engage. Also, you can put a manual override switch. All this does is switch it to ground. You can also use a temperature grounding switch in the cooling system of your engine block in the manifold or something. When the engine gets hot, it'll cycle the fan on. What the trinary switch does, it watches head pressure. The head pressure starts getting too high in that compressor, so it won't damage it, it cuts it off. It makes the fan run all the time. To make your air conditioner efficient, you need as much airflow across the condenser as possible, controlled by the trinary switch and your electric cool fan. Also, it's going to run your compressor, going to run your cool fan all through relays, keep the load off your switches, and that way if you follow the schematic, if you hook up your air conditioner, it'll work right. It also gives you a low pressure cutout because your refrigerant gas carries the lubricating oil. If you run your compressor low on charge, you can burn your compressor up. Not the compressor's fault, the fact that it's low on charge. So it's a nice safety device, makes your AC work great, follow the instructions, and it works good, and it gives you the options of the grounding switch and so on. So with all that, we got a relay. Again, relay is just a little electronic switch. I'm going to show you about relays, what all the numbers mean on it, how to wire it. That's next week. And of course, I'm going to show you some other interesting things like coil induction. You've got a 12-volt battery. You run 12 volts to your coil, and you get 30,000 volts out of it. Where does that come from? I'd like a refrigerator that I could put 12 beers in and get 30,000 beers. That would be awesome. So we're going to do a nice little coil test, show you some sparking and arcing. But I've had enough electricity for today. Right now, we're going to take a break. We come back and introduce you to our series-long Project 5-liter Ford motor. We're starting to build that up. It's going to be a neat little straight rod motor, nothing real exorbitant, but it's going to be a nice motor, so stick around.
Sam's Garage, presented by ARP, is brought to you by Advertising Edge, the official uniform of the NHRA. Flex-A-Lite, performance cooling. Easy Run engine stand, save time, money, and aggravation. ARP, proudly made in the USA, the world leader in fastener technology.
How frustrating is this? Get in a tight spot, you're down there, you can barely reach it. The end frame on this winch, from being used, it loosened up. I figured that out, but getting down here with the wrench, especially if you only have a 6-point box wrench, it's really frustrating. You can hurt your knuckles, cut yourself. Here's a great way to go. I don't know about you, but I like to find a way to make my life easier. Here's a little tool, it's called the Tight Reach Pro. This is the 3/8 drive version. Die-cast aluminum, powder coated. It's a professional tool. It is guaranteed for life. And you get some adapters with it. So I put in my 3/8 socket there, plug in my 3/8 ratchet there. This, by the way, is an extension wrench. It's got 10 inches of reach. Go down inside here, put it on the nut, and you do this. Wind it, the bolt, whatever you're tightening up. No cut knuckles, no broken knuckles. It's a real time saver. And again, like I said, it's guaranteed for life. And this thing is rugged. It'll take up to 400 foot-pounds of torque. And they've got other adapters. For example, when you're hunting in the toolbox for that 18mm socket, and you find you only got 1.5 inch drive, you got a 1/2 inch 3/8 adapter. Also have a little adapter that takes an Allen driver, okay? And you can use this with an impact gun. So they got it in this 3/8 version, and they also have a 1/4 inch drive one. Same thing, nice reach, saves time, saves your knuckles. On a job like this, you won't use it every day, but a job like this, you'll be glad you have it in your toolbox. Okay, I'm gonna go ahead and roll in the 5-liter Ford project and show you what we got. I just love my new shop. It's a great place to hang out, have a cup of coffee with the guys. There's a lot of traffic through here. Now, I told you we're gonna start on this episode of showing you our 5-liter Ford project. This is a 5-liter engine, and each week I'm gonna devote as much time as I can at the end of the show, going step by step to build up this engine. And at the end, we'll have it on our Easy Run engine test stand, all dialed in, we'll fire it up, we'll make some smoke together. Now, this is a 5-liter small block Ford, and this came out of a '92 Mustang GT. It was a good running engine, I got it right, took it over to my buddy Don at the machine shop, and I said, let's pull this thing apart and see what we need. He looked at it, he said, it's a pretty nice engine. Crank is standard, and it's straight. He polished it up, he said, good set of main bearings, and he said, I want to line hone it, so we put a set of ARP main studs. Now, he sent me back all the parts, and of course, these are the stock Ford bolts. They're adequate for an everyday car. If you stop making a performance motor, those bolts won't do it. But have the studs installed and installed properly, before you line hone it, because if you line hone it with the bolts and then you go to studs, you really should check it again because the caps can move. As you can see, it's only a 2 main bearing engine. It's not a Boss motor, but it's a nice little engine. So I said to him, you know, maybe we ought to think about boring it a little bit. He said, nah, it's already 40 over. So that's cool. I had no idea. The guy I got this engine from didn't know much about it either. So I had him check it. Look at those bores. He did a beautiful job. Cylinder finish is excellent. The bores are straight and they're really working pretty good. So he vatted it, line honed it, cleaned the bores up, put in new cam bearings. I've already started to acquire some of the components for it. Now, what I've got here is I've got some timing components, got a new oil pump, and I got some ARP stuff. I got a set of rod bolts. This is a externally balanced engine, so I want to use a really good harmonic balancer bolt to hold that on, and then I'll make a decision which way I'm going to go. Now look at the pistons here. I had him check them. He said, Sam, I'd use these pistons again. Again, this is a budget build. This is not going to be a $50,000 engine. It's going to be a mild street motor. Probably end up somewhere in the 300 horsepower range. We have a lot of decisions to make. Beautiful 40 over pistons. They're flat tops and they got the wedges for the valves. I had him check the rods for alignment, and he already installed bearings in there. But again, the weak link in a connecting rod is your connecting rod bolt. I got a nice set of ARP connecting rod bolts. We're going to install those and double check the rods. And then I'll make a decision on the pistons. You know, you have to decide whether you want to go with nitrous or a supercharger or a turbocharger. Then you need to start thinking about forged components. Those are hyper-eutectic pistons. So I've got a lot of decisions to make, but I'm going to have fun building this engine, and it's going to turn out to be a pretty nice motor right here in Sam's garage. And like I said, we'll fire it up and make smoke. Well, I had a ball here today in my shop. Hope you learned something. I'll see you next week.